Welcome to session 3 of the Big Picture 2 workshop. We've got a really exciting session planned for everybody today. Just going to introduce our speakers. So we have Kerry Howell, who's a professor of deep sea ecology at the University of Plymouth. She's worked on benthic video and image analysis for 20 years. She currently leads the Smarter ID project and is working on the application of AI to benthic imagery analysis under the Horizon 2020 Mission Atlantic programme. We have Dan Lear, who leads the MBA data team and is a project coordinator for DASH, the Medin Data Archive Centre for Biodiversity Data. Dan is co-chair of the Medin Data Archive Centre Working Group for Medin, chair of the Biodiversity Data and Information Group, BioDig, and a member of the OBIS steering group, leading the UK contribution through the UK OBIS node hosted at the MBA. And we finally have Graeme Duncan, who is a marine evidence manager at JNCC, covering QC, storage and dissemination of benthic data and providing technical data engineering oversight to the marine teams. He is co-chair of the Medin Standards Working Group. So I'll hand over to you guys to start.
Hello, I think I'm kicking us off. Okay, can you see my screen?
Yes.
Excellent. Yes. Okay, thank you. So today I'm going to kick us off then by talking about progress and challenges in the application of artificial intelligence, AI, to marine survey and monitoring. And I'm just speaking on behalf of the AI working group of the Big Picture Consortium, and many of whom are on the call today. So it's no surprise to everybody here that the use of cameras has seen rapid growth in the last 20 years, particularly. And although we're here talking about benthic imagery, it's actually true of the pelagic environment as well, through things like baited remote underwater video, BRUVs, as has been growing as well in the pelagic environment. And this vision of the marine environment, if you like, has absolutely revolutionized marine ecology, because it's allowed us to access sites that we were previously unable to sample. And this is particularly true in the environment I work in, which is the deep sea, in being able to access these incredibly hard substrate areas that are often very diverse, highly vulnerable, so coral reef type habitats, and has enabled us to gain a much greater understanding of these systems, the animals that live there, and how they live and also how they behave, which is another advantage of imagery and video work. But as you're all aware, this new technology is producing really vast data sets. So towed underwater camera systems, sledge systems, drop cam systems, static time-lapse systems, all able to now produce gigabytes, terabytes actually, of data on a single cruise or deployment, all of which requires processing. And this is particularly true of the very newer technologies, so things like remotely operated vehicles and more recently autonomous underwater vehicles. And the other device here is a sort of son of Bafisnat, which is a lander-based system that does time-lapse imagery as well. So these things can produce a huge amount of imagery and video data, all of which require processing by human annotators. And this is our problem. So huge data sets mean that individuals or teams of individuals have to sit and manually annotate these things. And it's hugely time consuming, which also makes it expensive. It requires a level of experience to do it well, but it's incredibly mind numbing. Anyone who's ever spent time annotating will recognize this face. It's just ridiculously mind numbing. So you can do it for a couple of hours and then it really starts to get boring, even the beautiful imagery that we see. And so at that point, then humans start to make mistakes. So individuals make errors, and that's a problem. But we also then have the issue of observer bias. So different individuals annotate or see things differently to others. And this isn't true just of imagery. This is absolutely true as well of physical sample data. So it's not limited at all to imagery. That different people have a focus on different things, and so we'll see different things. So this creates a problem because that error or that difference between observers is inconsistent. Oh, hello, is inconsistent. An inconsistent error is a problem when it comes to putting data sets together. But also, even within an individual, individuals are inconsistent themselves. So there have been some really nice studies that have shown that individuals who have analysed data sets and then 2 months later have analysed the exact same data set do not come up with consistent identifications. And so this is a real problem when we're trying to put data sets together to say something more universal about how the marine ecosystem works. And we do need to find ways of overcoming that. And standardization what's the word? So training, good standardization, good materials, training materials can all help to reduce that bias, but it doesn't overcome it entirely. So computer vision and AI provide an alternative, well, I wouldn't say alternative actually, a complementary approach to looking at image data and video data. And this type of image analysis, if you like, is not new and will be most familiar to people in the audience in the form of self-driving cars, or facial recognition software is a classic. If you use Facebook or any of those types of social media applications, some of them, you tag images with people in them, and eventually it starts telling you who they think is in the image. And so this kind of facial recognition software is a type of AI and is pretty widely in use. But the same technology and applications then can be applied to ecological imagery, and there are many open source tools available for doing this now. And there's been quite a bit of work in certain fields in ecology, not just marine, in looking at applying AI and computer vision to ecological imagery. But in the marine world, it's been growing rapidly, as you'll see over the last few years. So these open source tools are making it easier for ecologists to access computer vision and AI, but it's still not entirely easy. So it's in quotations there. So this type of approach is in development, and there are a number of teams working on a number of approaches within the Big Picture group. So I'll start with our team. So in Plymouth University, we've been doing some work led by Nils Piescher, who's on the call, looking at applying these approaches to AutoSub imagery data. And this was part of the Deep Links project. And so Nils was looking at an annotated line of imagery from this AutoSub deployment, and then looking at how well the particular algorithms we used were working in terms of identifying different species. And so we looked at how well they performed given different taxa, but also the number of training images required to get a decent level of performance, and also what happens if you change the number of classes, or how you group your data when you're asking it to classify things into different species or taxon types. So another really nice piece of work that came from a piece of work that was contracted by Scottish Government, so Marine Scotland Science. They contracted a company called Marinsol to do a review of automated identification of underwater life. And this is a really, really nice report, which provides a bunch of different case studies on how well different algorithms do, so older algorithms versus newer algorithms, in different scenarios of underwater imagery. So I've just taken a couple of figures out of there to show you. So one of the case studies was looking at identification or discrimination between between smolts and it was sprat and smolts, yeah. In the back of a trawl net with a camera in it, and also being able to track the individuals and count them, which was really interesting. Another case study was looking at counting sea pens on the seafloor from moving video. so a towed camera system. And this report is really nice because it looks at different algorithms. It has some really great conclusions in terms of the way different algorithms do better under different circumstances. And it also provides a really nice overview of where we are. And then I just wanted to mention a bunch of other people who are also working in this area within the AI working group. So Jen Durden's doing some really nice work at NOC in looking at this sort of thing, again, with downward looking cameras. Blair Thornton at University of Southampton's also got some PhD students working on this. I know Chris McGonigal at Ulster University is doing some work. Chloe Game at UEA, working with Guardline on her PhD, is doing some work on image color correction and this type of thing. And I think CFAS are also engaged in this. And I'm sorry if I missed people. I hope I maybe captured everyone. So there's a lot of folks in the AI group who are working on this and will have publications coming out in the near future that will contribute to our understanding of the limitations and the positives of this type of work. But as I mentioned, so the application of AI to this approach is really growing. So this is a piece of work by Erin Brown, who's on the call, who's my student, who's, please don't tweet this is part of her review, which is just looking at how this field is expanding. And you can see that a lot of the work is being done on fish, closely followed by coral, always the pretty stuff, the economically valuable stuff and the pretty stuff. And then plankton, and the rest of the benthic invertebrate fauna are catching up slowly. But there remain a number of challenges in the application of these tools in benthic marine image and video analysis. And these are some of them, and these relate to some of the tasks that we have identified then in the big picture working group. So the workflows at the moment are really complex and poorly integrated, and that actually runs from data collection right through to data archiving. So there's a huge amount of faffing with formats and joining files together that has to happen in order to be able to apply these things. And those could most certainly be smoothed out. The tools available still require a good level of programming knowledge, and ask anyone here who's worked with them and they'll tell you that. So it is still quite challenging for ecologists to work with. Although again, programs like BIAP are helping with this sort of thing, and Beagle as well. There's still research needed on the best ways to apply this technology. So the Marine Scotland Science Report was really useful, but things like, for example, is it better to daisy chain different algorithms together or nest them? Should you apply multiple algorithms and come up with some sort of ensemble approach? How should you group your taxa in order to get the best performance? So there's a lot of questions around, you know, what gives you the best results. There may be a need to further develop the tools, certainly to make them more accessible to ecologists, but in terms of the actual algorithms themselves, it's possible further development is needed, but I don't think we'd know that until we've actually gone into using them. And so I think the emphasis needs to be on applying the tools we have rather than writing new CNNs. Standards and protocols need to be developed in testing performance and establishing, you know, at what point something's performing well enough for us to be happy to use it and apply it to larger data sets. We need appropriate training data sets. So this is data sets of annotated images and video, and Graeme will talk a bit more about that. We need standardization in taxon identification and classification. So this is reference sets that which will give us larger reference sets that we can use to train AI. And I'll just give you an example of the old sponge 1, 2, 3, 4, which unless we're all calling sponge 1 the same thing, we're meaning the same thing, we can't put our data sets together for AI. So we need that standardization, and the Smarter ID project is precisely about that. And I think Jamie will mention that tomorrow. And there's a lack of training materials, and we need to develop those training materials to ensure the quality of that training material, because bad training material gives you bad AI models. So the AI working group, are sort of dealing, I think, primarily with this section at the moment, and we'll continue to work on these issues. I guess the vision, maybe it's a crazy vision, but I don't think it is. I think it's entirely possible. The vision is of, you know, autonomous vehicles being able to wander around the ocean, taking imagery, video, automatically interpreting it and self-training as they go, opening up just an incredible world of possibilities for our greater understanding of the marine environment. And so I will leave you with that vision.
We've got a hand up from Robin.
Yeah, hi. I was just wondering about the application for this type of software in different environments, such as those which might be subject to quite low visibility.
Yeah, so low visibility is a problem. I mean, it's always going to be a problem. It's a problem the same for a machine as it is for a human. So if a human can't see, I suppose, you know, the issue there is that perhaps you can develop the cameras to enable you to see better through through the water. But yeah, I mean, fundamentally, obscured vision is obscured vision.
Okay, great. We've got another hand up from Graeme.
Yep, this might be slightly hypothetical, but I'm intrigued. You first mentioned right at the beginning that one of the big problems about people annotating images is that, you know, they tend to differ between the two. And struck an interesting question for me is, you know, when we're moving into machine learning and sort of big data annotation, where you see the balance between being correct or accurate and being consistent, and if you know if one outweighs the other, or get your thoughts on that.
The thing about AI is it's consistent error. So consistent error is completely dealable with. Inconsistent error isn't. And I think as long as you can quantify that error, you can choose to or not to use the data. It's like anything else, isn't it? If you know the standard deviations around things, you can choose whether or not to use it. So I think that's the important thing is, and when I mention sort of standards, I guess it's, you know, these sort of things need to be decided in the same way that, you know, when you're thinking, I always think in terms of species distribution models, because we do those a lot, is, you know, at what point do you decide it's accurate enough to use? And I think that's something we would need to establish. And it might be that in different circumstances, you'd accept lower performance than you would in other circumstances. So then it becomes about the end use, I suppose. But as long as that is quantifiable, then you know where you are.
Great. So I've got one more hand up from Chris, and then there's a message in the chat. So Chris, do you want to go?
Yeah, cheers, Kerry. That's really good outline. Absolutely. The thing I was kind of really taken by with this is the need for us to kind of, rather than thinking about trying to necessarily upskill ourselves, is to think about how we can actively and more effectively collaborate with the computer science community in such a way that it avoids like unnecessary effort. Because I think there's a real danger that if you take a whole suite of marine ecologists and try and turn them into computer science programmers, it can, I don't know, it mightn't be the most effective way of approaching. Do you know?
I guess it depends, right? So in the world of, I like to use, I mean, it's very comparable, is the world of statistics. So there are people who write statistical methods, and that's their area of research interest, is they write the statistical methods. And then there are people who use those. And ecologists have had to become familiar with a variety of different statistical methods. And I don't really see AI as any different. You know, we do have to become familiar with using methods that are developed by computer scientists. At the moment, you know, they're just not that accessible. And so I think at the moment, there is a need to collaborate with computer scientists to help make them more accessible. But I mean, the conversations I've had with our computer scientists anyway, the conversation generally goes the same way. You know, they're interested in writing the algorithms. That's what their bag is. They're not really interested in necessarily helping us use them. That's a very different thing. So I totally agree. We need to collaborate with computer scientists, but I don't see them as the gatekeepers forever. I see them as helping us to learn how to do it ourselves.
Oh, completely. And I mean, the democratization of some of the techniques, I mean, they're increasingly, you're seeing this stuff kind of trickling down into the public domain through things that are, what would have been very progressive 5 years ago is now on people's phones in an app. You know, yeah. So there's the risk that, you know, I don't know, it's just frightening because I can see that sometimes we are becoming obsessed with the methods to the point that we're forgetting what we're doing it for, you know, and that's just a risk that I'm kind of conscious of myself, you know.
Yeah, no, absolutely.
But the main thing that I wanted to say, actually, it just occurred to me while I was listening to the talk, is that the idea of the training sets and the rest of it might be is a really good way of thinking. But another thing that might work really nicely is if we had a common data set that we could each approach with our different units and different organizations to try and see how much variability there might be in terms of the AI approaches, and to try and promote that like a hackathon, really, or something where you could bring a whole load of people together to try and basically crack the problem, you know?
Yeah, absolutely, Chris. And I think that's partly what FathomNet speaks to, actually, is you know, so the whole thing is the FathomNet comes from ImageNet, you know, which is the big data set that a lot of the people who design new algorithms use to play with and try and beat each other on who can classify a dog the best. And so I think the idea of FathomNet, but Kakani will explain in the talk, is exactly that, which I wholly support and think is a genius plan.
Brilliant. I'm sure, yeah, this may well be happening. These things are just occurring to me like a mad old man, you know. Just ignore me completely then.
Thanks, guys. We've got a question from Magnus in the chat, which is saying that AI is focusing on fauna. Is there any work focusing on sediment characteristics?
I certainly know the geologists are doing that, most certainly. They're doing exactly the same, but looking at how to classify sediment types from imagery as well. Dan Buscombe, there's a chap called Dan Buscombe who's been doing this for a while. I'm sure there are many other people, but his name always springs to mind for me.
Brilliant. And there's been quite a lot of talk about different image quality, like dealing with image resolution and poor imagery, and potentially post hoc processing of images in the chat as well, and talk of potentially bias towards things that are easier to recognize being kind of used first, and then there being a more of the cryptic stuff being less easy to identify, means that it doesn't get the AI development behind it. So yeah, and looking at color morphs for that as well.
Yeah, all good points.
Yeah, so really good chat. I think we'll move on to Dan if that's okay, unless anyone else has got any final pressing questions for Kerry. And okay, Dan,
okay,
over to you.
Thanks, Jess. Hopefully you have got the intro slide up now.
Yes.
Excellent. Right. Well, thanks, Kerry, for that kind of, vision of what's achievable. I'm afraid I'm probably going to bring everyone back down to a bump with some practical mundanities around the essential infrastructure and processes that we need to enable not just the AI approaches, but a lot of the things that we've talked about both yesterday and over the next couple of days to happen. So yeah, bear with me while I demonstrate some background thinking on based on a horrendogram that we've come up with around data flow. So this is sort of progress or work in progress about an idealized data flow to support the type of work and activity that Kerry's illustrated and is going on elsewhere. And it's really about how we can build a stable infrastructure to support these processes, and not starting from scratch, recognizing that there's a number of things in place already and how we can leverage those to meet the needs of the imagery community. So I'm going to go through this in a bit more detail, so don't worry if it's not immediately legible now, but this is the whole data lifecycle, if you like, for benthic imagery data flow. This is version 0.2. It's kind of been through a couple of iterations. So I got involved with this through following a conversation with Henk and Claire Postlethwaite, the Medin coordinator, and Helen Snaith from BODC, and I got pulled into it further down the line because of my involvement in Medin and the Dash Biodiversity Data Archive Centre. We've subsequently kind of followed that up, discussions with Graeme and Kerry. But what we're hoping to today is to get some engagement from the wider community and make sure we get some sort of sense check on this data flow process, whether it makes sense to you, whether it accurately reflects your needs from what a data infrastructure would provide to support the image work that you guys are all doing. So we're going to walk through this in a few steps, break it down a bit, identify some of the challenges around that, and then really throw it open to the meeting to discuss whether whether this captures the current state of play or an idealized state of play. So as I say, we're starting right from step one, imagery acquisition and the raw data that's being acquired. I would almost suggest we need a step zero, which is about making sure that you have a data management plan in place before you start your acquisition, and that data management plan should address all the standards and protocols and procedures that you are going to be adhering to in your data collection work. So following the acquisition, obviously there's a requirement to store that raw data after the initial quality control. So there's and Graeme's going to be speaking in a bit more detail about some of the challenges around storage and standards and how we can meet those challenges given the huge volumes of data that we are already dealing with and are going to be massively increasing with your 4K and 8K type video files. The big data challenge is very real, and it's one that is being tackled. There's other communities that are dealing with this. Kerry's had engagement with sort of the medical community looking at cloud-based analysis of MRI scans. It's being dealt with in the kind of climate world, in the space science world. There's a lot of other communities that are dealing with these challenges, and we need to make sure that we're not trying to develop in isolation, that there's lessons that can be learned from the wider groupings. But there's also challenges around the QC processes and streamlining those and automating those where possible. And what we need to make sure is that at every step through this process that we're maintaining the provenance of the data sets that are moving through the data flow, the workflow. And that provenance is really, what's been done to it at every stage. So we've got full transparency and replicability within that data. So moving on, steps 3 and 4. This is the processing data and making it ready for analysis. So, and then moving through to the annotation step. The big green box here at the bottom, this analysis ready imagery, really is the sort of the exemplified by some of the work that FathomNet are doing. And again, we've got the short video today and the longer workshop session this afternoon, looking at that in a bit more detail. But the challenges around this, again, storage is the consistent issue running through the whole of this workflow and data flow process, but also about standardization around tools and software. There's a bit of a discussion yesterday in the context of the EIP tools about looking at how we can get that degree of interoperability across the tool sets that are used at every stage. Yeah, so then we've, like I say, moving from the processed imagery and the analysis and the annotation that goes on either by human eyes or through the computer-based tools that Kerry outlined earlier. And the final 2 steps in the workflow is the kind of storage of records. So turning the annotation into the more traditional occurrence-based records that we are relatively good at handling. Actually, we've got quite a good established workflow through the MEDIN and the NERC data archive centres, and how those records then flow into the wider community. So I'm thinking about our interactions with national repositories like those promoted through MEDIN, but also internationally through OBIS, eModNet, ICES and OSPAR. And that then sort of feeds into making the information useful. So how we interpret the outputs in a form that is digestible and accessible for management, policy making and decision making. So turning the outputs from the analysis into meaningful or synthesized information. And this is kind of being delivered through the sort of dashboard type summary information. So there's a further step on how you transform essentially rows and columns into something that can be easily interpreted and used within the policy making sphere. So again, the storage records, and again, we've got a little bit more discussion on this later in the session about how if records are split or divorced from the image that they were derived from, how we can reaggregate that, how we can make sure that the links are maintained between these data, and particularly when data are collected alongside other contextual parameters. You could probably sum up the entire data flow process as about making benthic imagery fair, and this fair buzzword is something that hopefully many of you are familiar with. It's used a lot in the data management world, but it's kind of creeping in elsewhere, and it's an acronym for findable, accessible, interoperable, and reusable, and it's really sort of the basis on which Medin is now moving forwards on making all marine data fair, but you can apply it at different levels and at different stages within the process. So really, yeah, that's kind of the take-home message. There's questions now, as I said at the start. So to put out to you as the group, as does this reflect your reality? And maybe you only interact with a subset of this process, but is it true to, or should it? How can we move towards it being true for you? Is anything missing or wrong within it? And I guess there's a question about which areas are critical or priority areas to get right. Where do we need to focus our attention? All these feed into specific tasks and activities within the action plan for the big picture. And maybe we need to look at which ones of these we should prioritize in order to kind of potentially either unlock funding or unlock research and development activities that we can all benefit from. So at that point, I'll kind of stop and throw it open to the floor to provide some feedback on the diagram.
Fantastic, thanks, Dan. So again, if people want to raise their hands or post in the chat with any questions that they have, we've got Jen Durden, you're quick off the mark if you want to come in with your question.
Hi, Dan. Thanks for your horrendogram, as you call it. One of the discussions that we've had with BODC over many years now has been about how many copies of a single piece of imagery they would retain. So, because I see you've got in different places here, you've got like for example, on the left, still imagery raw, and then you've got still imagery processed, and then you've got some other processes in steps 4A and 5, 6, whatever, about different aspects of that. And so, the processing could involve several things. It might be altering the content of the image. I'm thinking of things like color correction or whatever, but it might also be subsetting those images, removing the ones that are too close to the seabed or, full of sediment or something like that. And so it kind of changes what the set of images is at each step. And so we usually keep, I would say, all copies of all steps in the process, but that could end up having a massive storage problem, as our image sets get bigger and bigger. And so that's not something I think we've got necessarily to the bottom of. And I was wondering how that fits on your diagram here.
No, I think you're absolutely right. Obviously, it's a huge challenge, and you need to have that ability within your workflow to backtrack, and that speaks to my point about provenance and understanding what's happened at what stage. Yeah, I don't think we've got an answer, to be honest, at the moment. I think it really depends upon each use case, and as we work through it, and that's part of the reason for this discussion today, is to say, how many iterations are needed to be retained, and whether you can, if you have a a well-defined workflow or set of steps, whether you only need the original and you have that workflow defined and machine actionable, you can repeat it. It makes it repeatable, whether you need to store those intermediate stages or not. But again, it's very much driven by the end user.
Okay, great. We've got another hand up from Henk.
Yeah, thanks, Jess. There's sort of a number of things flying through my head at the minute, and I sort of want to just focus on the main ones. I guess storage is storage one of our big things, Dan, Kerry, and Graeme? Like, I mean, actually, it is. Jen's quite correctly pointed that out. So, I mean, I don't know too much about this kind of stuff, but there's that rule that sort of programming power increases every 2 years. I don't know who came up with it, but storage increases every 2. So in theory, should, say, in 10 years time, should we have the biggest, most massive, crazy sized storage capacities, and provided we don't keep on upping our image acquisition, resolution, data frame collection rates, and general size of imagery, we should get to a point where we've got, or will we get to a point where we've got more storage than imagery, and then it's just it's a question of storage. That's like, I guess that's maybe that needs to be a key task, is find cheap storage.
Yeah, I think it's Moore's law that is the doubling of processing power every few years. Yeah, and I guess, well, that's a potentially a fantastic segue into Graeme's presentation about storage and the need for centralized versus distributed. My opinion is the storage. We don't need a central monolithic storage solution if we get our standards right and our interoperability right. If we sort that, it doesn't matter where the data are, as long as we've got that access, standards-based access. There's a lot of nuances, around that as you dig into it, but broadly, I think that's my take on it. There's certainly solutions around cloud storage and opportunities around that we can look at and explore. But getting the standards right is the key to tackling the storage problem. I don't know if you want to come in there, Graeme.
No, I'll leave the detail till later, or a bit of detail. But I was going to say, certainly for images, I mean, video is another ballgame altogether. But for imagery, I would say, yeah, physical storage isn't the issue. Storage is pretty cheap nowadays, certainly in the cloud. It's the governance, so keeping track and managing as a person or as a system as you're increasing the number of images is the main issue of scale I can see.
Great, we've got a couple more hands up that we'll go to. So we've got Clive first.
Yeah, hi. I mean, it was just, just to think about why you want to store, all the original imagery. So I mean, the example I've got is some video projects I've been doing, with Marine Scotland, and they ask in the contract us to sort of store all the original video. They've never asked for it. What they're really interested in is the final report and the result. So, I mean, I can see, yeah, you might want to reuse some stuff. Maybe you need to go back to, if somebody challenges your results or something. But I think we should think a bit more carefully about, really, do we actually need to store everything originally? Why are we doing it? Just hoarding it away,
Yeah, I think there's a very human, well, certainly with my data manager's hat on, a very human drive just to keep everything, just because we might need it one day. But I guess my counter in a way to that would be that we don't, 20 years ago, we wouldn't have understood or wouldn't have had a clue about the opportunities we now have available to us, and maybe in 20 years' time that those data will be used in ways that we can't predict. If the storage is cheap enough and we can kind of glacially store it for a while with minimal cost, then why not? As long as you've got the ways to reprocess it, and again, that's the sort of machine actionable side with minimal human effort and interaction. Then, yeah, there's a questions around future potential reuse, I suppose.
Okay, great. In the element of time, I know we have quite a few people with hands up, but we do need to kind of push on, unfortunately. So if people want to put their questions in the chat, maybe Dan can have a look in there and answer any questions in the chat for the moment, or we can come back to it at the end if we have time.
Yeah, we've scheduled some time at the end, hopefully.
Okay, so handing over to Graeme now.
Thank you very much. So if I just try and share my screen here. Right, is that showing the much said phrase of this?
Yep.
Cool, grand. So yep, like Dan said right back there at the beginning, I'm going to talk a bit more about, I suppose, focusing on the middle of that diagram and going into slightly more detail on just looking at the challenges really that are inherent in trying to get all this talking to each other, and especially with a focus on Kerry's talk with machine learning as an end customer, as it were. So basically looking at the example of image catalogues or image stores. Now, image catalogues aren't a new thing, and they're being sort of increasingly common amongst agencies, mainly moving from an internal need, moving from all your images just being stored somewhere on a file drive in a network and rather difficult to access or search for. Maybe you've got a a spreadsheet that you can look for. Moving on to sort of, I suppose, full image catalogues, which are there to let you easily find, access, and serve up those images. So they're not a new thing in itself. They're also a really interesting thing as far as sort of this area of work is, because they're an interesting sort of amalgamation of both the images and the underlying data themselves, and that's usually due to enhance sort of the searchability of the images on the catalogue. You usually have to go in and tag the image with, in effect, what species may be in the image, the habitat of the image if you're doing that, and all sorts of what are in effect sort of data outputs of the image or metadata on the image back in as metadata to help people find and use the image appropriately. So there's a weird internal loop there already in terms of trying to manage this feedback and finding out which data are suitable to be sort of alongside the image itself and which data are true data. And the other aspect which we're coming increasingly onto is, as Kerry mentioned, imagery is increasing in terms of numbers, not only in the numbers that are coming out of surveys per organization, but with the number of organizations that are collecting imagery, and they're collecting imagery that are good enough to do some sort of machine learning or human annotation or some sort of analysis out of, and trying to find a way of structuring or organizing all these disparate sources of images is an interesting challenge in itself. And so one of the ways that you can think about this really is in a sort of a centralized versus distributed model, and thinking sort of almost like a shop, as it were. So in a centralized model, you have your one shop, your one sort of catalog, your one front end that people are interacting with. People are always going to the shop to get this thing, to purchase their goods. But behind that shop, you would have multiple providers that are just dumping their images, in this case, or their products into the shop. But the clients, the customers, don't ever interact with the producers. They can only ever access the imagery from the one place. Now that's different to your distributed model, whereby in effect every supplier has their own front end, every client has their own shop, and the people can access the images from whichever shop that they want. And that's actually the situation that's sort of starting now. There's certain organizations that do have their own image catalogues and provide access to the images through them, and the open access images and the public are perfectly able to access those images, but it's a per supplier, and that causes a bit of a issue. It's a bit chaotic. Suppliers might not know exactly where to go to. You know, if someone just wants an image of one thing, you know, you're going to have to go to 4 different places to actually get it. And so you can move to sort of, in effect, a distributed model, but with a broker in the middle. And what the broker would do would be to provide a single access point to all of the shoppers to take their orders and let them find out which shops behind the scene are able to supply the you know, the answers to those orders and provide that back. So it provides an umbrella over the top. And I mean, this is the model that your general online shopping behemoths go for, where there's just one access point, but behind the scenes it distributes it out to different organizations. And of course, as part of that, there is nothing stopping anyone, if they want to, directly accessing a single shop. I said this is the model that most online shopping systems use, as a bit of an idiom, but there's not a sort of a clear-cut winner between the two models behind centralization and distributed. These are just some different ideas of pros and cons of each different type of model that there could be. So, you know, if you put all your eggs in one basket, as it were, you've got a lot simpler sort of management and setup. You know, you've just got a single place to make sure everything's correct and to serve everything. It's technologically generally simpler to do. It's easier to quality control because to get into the one place, you've got to meet the criteria. But it takes control away from the providers. You know, they might have different reasons for storing images that if they have to put it into your system, they can't serve. It's less flexible. Again, catalogues already exist. Do you duplicate them or do you shut down the individual catalogues? You have to scale this vertically. So what that means is, as Dan said, as you add more images, you basically have to just increase your image store to a sort of a behemoths size and deal with the data there. But a big potential benefit is you can actually move the processing exactly to where the data are. And in the distributor model, obviously you coming back from the other direction, it's more complex to actually set up, although to the user it shouldn't look any more complex. Everything needs to talk in the same language together. It's harder to control because you're trying to in effect herd all of the separate disparate data catalogues into doing the same thing, but it provides more control to the providers. It offsets a bit of that management to the providers, so you don't have a single massive thing that you have to manage and maintain. And it's a bit more flexible, and you can scale it horizontally. If you need more images, you just add a new little image catalog that talks to this central broker in the middle. So that's one thing to think about. Just in the interest of time, I'll probably just welcome thoughts in the chat on this aspect, and we can probably come back to them if there's time at the end of the session. But judging, sort of trying to decide sort of which avenue we go down to, or whether we start in one area and move to a different model, is something that we are thinking of and working towards as part of the working group. And that's just talking about whole images themselves. You know, that's just saying, I want this full image. Can you give it to me? Yes, no. You end up in all sorts of other sort of complexities when you go into the world of annotations. Everyone knows hopefully what annotations are here. It's a specific point or shape or basically area of an image that is tagged by a specific thing. You are saying that those 4 things on the left are buttons. That is an eye within the circle, that sort of side of things. So it is a specific thing at a specific place or area in the image at a specific time if you're dealing with videos. But the thing needs both a label and a context. You need to ensure that if you're talking about sand, for example, are you talking about sand in the folk context? Are you talking about sand in a different context? And this level of annotating things is not handled well by a lot of standard image catalogs. So the end point, the things that are designed to serve the data out. But obviously they're handled well in terms of generating the annotations by a lot of modern software that's coming up, Biggle, Squiddle, VRMA, and all that sort of side of things. And as of yet, there's no sort of known standard way of annotating biodiversity imagery, or at least marine biodiversity imagery, sort of to the level that we want. There are annotation standards out there, things like the W3C annotation data model, which is actually very useful, and we should probably build on top of, but is very, very generic. It's a framework and just would not serve our needs, and more than on top of that, probably wouldn't be understandable to most of the users that are either putting data in or getting data out of this thing. So we need sort of a nice shiny thing over the top of that can provide a bit easier access to your annotations. And annotations, again, they bridge the gap between data and images. So there is a question which needs to be worked out when we go towards sort of the end ecosystem really of these images, of whether the annotations should be part of an image itself or whether they should be their own thing, their own sort of data thing that simply references an image. And that's actually the approach that W3C take, that an annotation is its own thing and it just references an image and a label. So that's another thing to work out, where we put these annotations separately or inside of the images themselves. And that's, again, talking just about your image catalogues themselves, not even looking towards your reference catalogues, which in, I suppose, the classic days would be in effect a set of cropped photographs that were delivered as part of a package saying, this is specifically what we are talking about when we are talking about this taxa or this morphotype, which is moving towards systems like Kerry mentioned, such as Smarter ID. And from a machine learning perspective, it's interesting because the images on the left are really what the machines are going to try to identify objects in. But the reference catalogues themselves make very good training data sets, or at least the idea of what an image reference catalogue is doing makes very good reference training data sets for machines. But looking at that and going back to what annotations are, in terms of looking at the ecology, as it were, or the environment of these systems, an interesting question to raise here is whether the idea of reference catalogues are a special set of annotations that are delivered alongside an image. It is saying, this area of the image is of this taxa, and it is a particularly representative example of this taxa, but it's potentially still just an annotation, and therefore when we're building a system, it could be taken into that context. And that's all well and good. Generally, with your lovely model here, looks quite nice when there's people accessing it. You end up in a whole world of trouble when you try to get machines to access this area, especially if it's not got a broker in between it. And that's because machines are very clever at doing one thing, but not particularly clever in other instances. If a person wants to get something from a shop, they ask for an apple. The shopkeeper says, yes, there you go, you get your apple. That's fine. A different person can go to the shop and say, sell me an apple. The shopkeeper knows what they're talking about still. They know the context. We'll give them the apple, that's fine. Computers are different. They're very naive. So, and these are all sort of real instances of what computers tend to do, but turned into lovely robots. So one example is they try to access the wrong point to do something. So this person is trying to get an apple sold to him, but not in the actual shop front. He won't get what he's asking for because it's not the right place to ask for it. You can get it all working well. You know, this you can get your apple like a normal human being, but go to a different store with a different custodian, ask the same thing, and they might be expecting you to say something completely different. And instead of trying to work out a context, it will just throw an error and you won't get your data. Similarly, you can ask for whatever you want, you can get it back, that's grand, but the client on your side might actually not recognize that the shopkeeper has given you the apple, and he could actually just walk away without the data. And the inverse example of that, you can ask for an apple and the vendor could reply with something that sounds like they are giving you what you're asking for, in here the word okay, but actually giving you something completely different. And generally the computer at that point would try and eat the documents and end up with all sorts of problems. So really what we need to do here is whatever we go towards, the solution really needs to sort of hold the computer's hand as much as possible to guide it and make it as easy and as consistent as it can be to asking the correct information and understanding the information that it gets. And these are generally handled by two things, which is interoperability, which is in effect sort of knowing how to interact, knowing where to go to ask a question and knowing how to ask the question. And standards on top of that, which is knowing what you're going to get as a result of that. So interoperability actually is fairly well handled in the general imagery world. There's something called IIIF, which won't go into too much detail, that is all about this. It sets a standard sort of framework or API, which is just a means of accessing stuff, for accessing imagery. It says if you ask it in a certain way, you'll get a certain thing back. And that's either for an image or, interestingly, for part of an image. Based off of the same raw image, you can ask for a specific region, as it were. And that's done, don't need to know the detail, in a way that looks like this. On the left-hand side, they're asking for the full image here, with exactly the same way of talking about it. In this area at the bottom, for the same image 1, 2, 3, 4, they're asking for a particular region, and they will get that region back. And this is a potential way to tie in things like your reference catalogues into your annotations back into your raw imagery, whereby the reference catalogues could actually just refer to a specific region of the image, and the machine would put the two together and get the region back. But it doesn't describe what to search for or exactly what you'll get back. And that's where the standards come in. And there are already standards out there underneath MEDIN for the imagery standard, but there are a lot of gaps in the standards that we'll go to in a second. So with all that in mind, making it all connect is interesting, to say the least. So you could have potentially multiple reference catalogues out there that are referencing imagery. You can have multiple imagery out there that are getting referenced. And as an end game, one solution that you could do is to, in effect, put a little broker in the middle of all these things so that they can all have a centralized point to talk to each other. But that's pretty complex. So instead, you could just start off with a pilot study of a small centralized system with the means to build on top of that. So that's one potential way that we could progress this. And once we know that this sort of system works, then build on top of it in terms of the different disparate systems talking to each other, different catalogues and all that side of things. So that's potentially one bit of work that we can do. So moving forward, we need to first determine each item's sort of niche in the ecosystem. We need to fill in the missing gaps in the network. So where these centralized catalogues don't exist, there needs to be one. And we certainly need to adapt or develop the standards for our own purposes of marine imagery. There's imagery metadata there that already does exist in MEDIM, but this is a very good use case to potentially test and adapt to that. One big thing that is completely missing is, as I said at the beginning, an annotation standard that works for marine imagery. That does not exist, and that is something that we can work towards, either building off of existing ways of producing annotation or building off of the foundations that have been set there by broader annotation frameworks. And then onwards from that, moving towards a pilot framework or ecosystem for your image catalogues, taking into account the images, your annotations, your reference catalogues, and something that Dan's going to talk about in the future, linking that back to actually the data itself. And so finally, one of the last bits about this is what the sort of working group really is aiming towards, or one of the key aims is actually providing a link between the other working groups, the working groups that are producing stuff and the working groups that are consuming stuff, and ensuring that it sort of meets in the middle. And obviously keeping machine learning as one of the key customers moving forward. That's the end of my side of things.
Fantastic, thanks, Graeme. I think we've probably got time for a couple of questions, and then we'll have to move on. So if people want to raise their hand, there's been a lot of really good talking in the chat whilst you've been presenting, Graeme. Lots of really good discussions and thoughts about different things. Jen, if you want to come in.
And one of the challenges we've really had with catalogues is management, like keeping them updated and version control, etc., in conflict with appropriate sort of attribution or valuing of that catalog. So as an academic, it basically needs to be a published paper with a DOI and an impact factor that's already established, etc. So putting it online has very low value for us. Whereas putting it online has high value for other people that might want to access it and use it in an open access context. So that's something that I don't think we've been able to really reconcile. Certainly people have chosen to do one or the other. There's quite a lot of image catalogs now being put into, for example, Biodiversity Data Journal or things like that, which takes them into a more inaccessible online format, but provides them with the credit that they need for their academic careers. And others that have gone, for example, Mbari has a totally online deep sea guide, their entire taxonomic guide, which includes substrate as well as organisms. And they have someone dedicated to keeping that updated and maintained. And I think this has resulted actually in a lot of image catalogs that are just not available to people outside the institutions where they were developed. So a lot of that information is not being shared. I'm certainly guilty of having one of those catalogs that's not available to others. So I think that's still a challenge to a barrier to working on the catalogs. And the second piece of feedback I was going to give was just that I think that catalogs and training data sets for AI, whilst they might have an overlap, we end up with a couple of problems. One, currently most of the AI projects need to be tuned per image data set. That is, they need to have the same background, lighting, camera, etc. conditions, whereas it's useful in a catalog to have those vary considerably and have images from multiple image data sets in order to give somebody the most possible good views of something. That includes images from different perspectives, not all, say, downward or oblique images or whatever, but may include some combination of still imagery and video. And as such, those two things can't necessarily be interchangeable, but they do have some overlap.
Yep.
And the last thing I was going to say is, the word metadata makes me cringe because one man's metadata is another man's data.
Yep.
And it's used to mean many different things. So, for example, in the AI world, computer scientists, when they say metadata, they mean annotations. They don't mean when your picture was taken or where it was collected or how big it is. So I try and avoid using that word at all costs. After some advice from Christine Borgman, who's written a really good book about data, big data, little data, no data.
Yep, I can try and answer each of them in turn as we try and remember what the first one is. So yeah, in terms of supplying imagery and image catalogues, and I suppose the cost of doing that, versus the value from the other side, I think that's certainly where whether you go to a centralized system or a distributed system, having in effect like a public catalogue that is open for people to put data into is a good thing. And that's certainly where, like organizations like Dash potentially, could provide a service that, say, if you can't put your sort of chucking things Dan's way here, but if you can't create your own image catalog, just give us your images and we will help you to actually make them publishable. And you could get your imagery up that way with hopefully less cost from your side. And then on the last one, because I've actually forgotten what the middle question was now. I do agree. Metadata, it means something completely different depending on what you're talking about. Obviously, I'm from a data management perspective, so yeah, metadata is simply data about data. It depends what the data you're talking about is. But I agree, it's a very confusing term, and trying to come up with, I suppose, ways of properly describing what type of metadata we're talking about is definitely something that needs to be worked on. And I forgot. Sorry, I apologize. I've completely forgotten what your middle question was.
Oh, it's just about the overlap between
oh, that's right.
guides and AI training data.
Yeah, sure. And the fact that if it's in a central image catalog, there's just everything's in there, and you need to do post processing or other things, or take into certain context the batch of the images that it was taken in. And to me, going back to abusing my own point of metadata, that is actually where metadata on the image does come into play, because you could you would say this image is part of this survey. You could even potentially add saying it was taken at this angle, and all that sort of stuff. But working out what bits, which pieces of context are required by machine learning algorithms to do their job properly will help drive what, in effect, sort of metadata fields we need to ensure that the catalogs have, so that you can access and subset the data correctly.
Okay, great. Okay, so moving on, it is you, Kerry, talking next about more about AI data.
That's a very good point. Sorry. Yeah. Okay. So I mentioned it earlier, is the FathomNet project that Kakani at Mbari has been working on, and has kindly sent a presentation, a short video on, which we'd like to show now. But I kind of already alluded to the purpose behind FathomNet, but Kakani will explain it much more clearly than I will. But it's this idea of a central repository of data, or a data set that might attract computer scientists to want to work on it. So it's like the marine equivalent of ImageNet, and if we can attract that computer science community to our data sets and to use them to work on, then it might actually facilitate better communication between these organizations. But it's so much more than that. So I'm just going to play Kakani's video and shut up, actually. All right, can you see?
Yes.
Yep, you can see it.
Let's hope the sound works. I did press the button.
Thank you for checking out our project. My name is Kakani Katija, and I'm excited to share with you FathomNet, exploring our ocean using artificial intelligence. This is a project that involves a number of individuals from NOAA, National Geographic Society, Sea Vision AI, MIT Media Lab, as well as Mbari. And also funding has been graciously provided by the National Geographic Society, NOAA, as well as National Science Foundation. This project really centers around one question: how do we explore a realm as vast and ever-changing as the ocean? With the advent of modern robotics, persistent and distributed observations of processes and life in our ocean are now on the horizon. Implementing artificial intelligence, or AI, has been touted as a crucial pathway to enable rapid processing of ocean data. And this is really required in order for us to be able to scale our observations to the entire ocean. Adoption of AI in the ocean is limited, though, by the availability of curated data, particularly underwater imagery and video, in order to train these algorithms. And so our ocean shot is to use AI to automate processing of underwater imagery and video to fully explore and discover our ocean. And really to realize a vision of ocean exploration and discovery that involves the use of distributed observation platforms, conducting measurements at unprecedented spatiotemporal scales. Now, artificial intelligence can help, but in order to train algorithms that can automate the detection and classification of concepts in underwater imagery, we really need labeled data. Labeled data requires localization, or bounding boxes, and identification or annotation of concepts in every training image. But the bottleneck for deploying AI in the ocean is the availability of labeled data, which FathomNet seeks to address. And we're able to do this by first leveraging existing data like MBARI's video annotation and reference system, which is a 30-year annotated database from ROV collected video. And if you do a search for a concept like Aegina in the VARS database, you can return a number of images like the two images that you see here just on the left. Where the top image shows Aegina clearly as the only object or concept in the image, whereas the image below that shows Aegina with a number of other objects. And so while some underwater image data may contain annotations with concept names, in more cluttered fields like the image on the bottom, the locations of all concepts within an image are critical for training machine learning algorithms. And so our solution then is FathomNet, which is a publicly available database for training machine learning algorithms on underwater imagery. And by leveraging existing data and providing a repository for new data, we will construct a global data set that can be used to train algorithms for rapid and widespread exploration and discovery of our ocean. To date, FathomNet contains 771 concepts and more than 117,000 localizations from MBARI's video annotation and reference system, with additional contributions from NOAA, National Geographic Society, and other partners planned in 2021. Training AI algorithms on FathomNet data have yielded promising results that can be used to achieve our ocean shot. Now, FathomNet can be found at www.fathomnet.org, and the website will be released in the next few months. And users can either search for concepts from the website directly or by using an API. Data exploration involves the use of concept trees, geographic locations, or a number of other filters, and contributions can also be verified by experts. There are also additional annotation tools that can enable users to augment existing data or make modifications to data that they contribute to the database. And algorithms trained on FathomNet have been used to detect and classify animals observed by numerous deep-sea robotic systems at MBARI, NOAA, and NGS. And the videos that you see on the bottom are examples of footage that have had machine learning algorithms applied to them, collected by these different robotic platforms, including NOAA's ROV Deep Discoverer, National Geographic Society's Deep Sea Camera System, MBARI's Mini ROV platform, and finally, MBARI's I2Map autonomous underwater vehicle that is specifically designed for midwater transects. And if you want to learn more about these applications, feel free to use the QR codes on each of the videos to find out a little bit more information. And we're very, very excited about the potential that FathomNet could have to finally address and achieve our ocean shot. We're grateful for the funding support that we've received through NOAA, NGS, as well as NSF OTIC, and as well as the David and Lucille Packard Foundation. We're also indebted to many, many individuals who have contributed to this project. So if you have any questions or concerns, please contact myself or Katie Croft Bell, whose contact information I've also included here. Thank you very much for your time.
Okay, so hopefully that was fairly self-explanatory, but in terms of our work, what I should have said at the start, which I will now say, is FathomNet is perhaps an example of the green box in Dan's diagram that he showed at the beginning, and is one option for that archiving of annotated data to support AI. And it's something, I guess, that we may want to think about at a national level, or even, at various levels, but certainly some sort of national archive, be it distributed or what have you, is something we maybe want to think about. And I think I'll hand back to Dan, possibly.
Okay, unless there's any, I mean, I think we've got opportunities for questions in the session late this afternoon with the FathomNet guys, so I'm not sure we're in a position to answer those now. In the chat and also in some of the presentations around the challenges around data flow, and Graeme mentioned specifically, the fact that how we can, or the fact that sometimes data gets split and the challenges around reaggregation. So I'm just going to spend a few minutes on data flow, but also I think it's probably worth stepping back a bit and looking at the data landscape that we're working in within the UK and how it interacts at a sort of regional and international level, because I'm aware there may be people on the call who aren't necessarily as painfully familiar with the data management landscape as I am. So sort of nationally, and Henk mentioned it yesterday, that the big picture sits within the UCMAS framework, the UK Marine Monitoring and Assessment Strategy, and the Marine Science Coordination Committee, and reports to the one of those implementation groups, the Healthy and Biologically Diverse Seas Evidence Group, or HBDSEG. So that framework also includes MEDIN and its network of data archive centres, and the work MEDIN does in the establishment of data guidelines and data standards. Alongside that, you have the sort of the more academic side of things, if you like, the UKRI network of environmental data centres, which BODC includes, and BODC is also a MEDIN data archive centre within that UCMAS framework. But you also have a number of possibly what I'm unkindly calling silos that don't sit within the broader national infrastructure. So these might be sort of institutional or thematic data stores that may or may not have wider interoperability. The international publication endpoints that we interact with, you have groups like EMODNet, the European Marine Observation and Data Network, which has both a seabed habitats and a biological strand, the Ocean Biodiversity Information System, OBIS, and also the data infrastructures, again, were mentioned yesterday within ICES, but also some of the reporting requirements that we have in the data center that supports that through OSPAR. And more broadly, outside the marine realm, you have the Global Biodiversity Information Facility, which provides a lot of the broader biological data standards for the occurrence type data that gets captured. So moving kind of nationally, this is the, again, I love my complex data flow diagrams. This is the data flow that DASH sits within. So DASH is the UK Archive for Marine Species and Habitats, accredited through MEDIN, and also operates as the UK node of OBIS, run from the Marine Biological Association in Plymouth. And as I said, we're accredited as a MEDIN data archive centre, providing support to the UCMAS community to manage and publish biodiversity data. And I think, it's fair to say that our focus thus far has been on your traditional occurrence, tabular data and imagery data across the MEDIN community hasn't been particularly well served. I think primarily because it's, as we're all painfully aware and becoming more aware, it's it's complex and it's costly, but that's why it's fantastic to have this big picture community established to try and tackle it and drive it forwards. So Dash sits within this context. You know, we have a data exchange agreement for terrestrial and marine data with the National Biodiversity Network, but also with a publication platform onto OBIS, Eurobis, and eModNet Biology. Once you step up to the kind of European scale, it gets even more complex again. You have a number of both thematic and national nodes within OBIS. You have data interoperability with GBIF, but you also have a number of the S3, the environmental science research infrastructures, things like LifeWatch, that again have their own data, but also want to interact and access data held within these European and global aggregators. So again, bringing it all back to our moving away from the green box to the brown box and the records and storage requirements. So this is where the annotation information coming off the images gets turned into, again, more traditional occurrence records, and how we handle those and how we ensure that those records retain that link back to the imagery that they were derived from. And it also hopefully potentially addresses some of the concerns or issues raised in the chat about how we better acknowledge the information or the provenance and the provision of the data from the individual researchers. So this is the kind of the use case that I've just shown, kind of simplified down. So traditionally, you'll have your image, your annotated occurrence data that comes from that, and we'd ingest that at the moment within Medin. But when we publish that on to these aggregators, or when they harvest from us, that link's broken. You know, they take the traditional tabular data, but currently aren't in a position or have the infrastructure to capture that that link to the imagery data. So how we tackle that, and this has been piloted in a small project that we've done through Medin funding, is to develop a way of ensuring that the link is maintained. So we've had a pilot project called MAIMS, the Medin Automated Image Management System within Dash, and this was using an adapted digital asset management system called Resource Space that has a publicly available API. It's open source application. It's also what the JNCC image catalog is built on, and a number of other organizations. And so what we've been able to do, because it's an open source application, is to modify the metadata that, and yeah, using the M word again, that underpins it, and to align it with the Medin data guidelines. So it provides a platform whereby you can search imagery and link it back to that underlying data, and vice versa. So the traditional data that's published through Dash can be relinked back to the original image source. The way we do this, and again, it's a challenge across all areas of data management. It's something that Medin has been wrestling with for a little while, particularly to do with sort of multidisciplinary data sets, where those data sets are split between the different thematic data centers. How can we aggregate that? And that's primarily dealt with through high quality metadata, the caveat being that this is discovery metadata, the who, what, when, where, why, and that it's technically implemented through PIDs, or persistent identifiers. One of the ones that we've mentioned already is the DOI, the digital object identifier, but the one that, again, a lot of academic and researchers are familiar with are ORCIDs, which uniquely identify people. But you also have the RAW identifier, which is for research organizations. And through a combination of these, and the embedding of these within the metadata, it allows disaggregated data to be reaggregated in a machine actionable way. And that's the kind of the aim, is that if we can build systems, tools and processes that are machine actionable, what we do is we remove the barriers and reduce the friction to the reaggregation of this data. The advantage being is that it also unlocks the potential for data to become citable in its own right. And there's a lot of work going on within the data site community. There's a large Horizon 2020 project that's looking at how data can be recognized and put on a platform to make it more citable, more attributable to the source researchers. So we're a long way from, you know, the current academic model of you being judged on your peer-reviewed publications for data, but it is moving in that direction. The other opportunities that the use of these persistent identifiers unlocks is that of a network of linked open data. So the use of persistent identifiers again allows this machine actionable interoperability between data sets that you wouldn't traditionally have linked, or could or providing ways of developing metrics of success and research outputs that you wouldn't necessarily traditionally have used. So within the MBA, we're now looking at how we can present sort of dashboards of research outputs that not only capture the peer-reviewed publications, but also the data sets linked to that individual researcher. And that's delivered through the use of these persistent identifiers to provide a standards-based way of doing it. So this is definitely an area that is currently technically possible, but the processes and the workflows are still evolving and still needing work, and how we can do this and the levels of metadata and the standards that we apply, going back to Graeme's point about the current absence of an annotation standard, are certainly areas that we want to address through this working group within the big picture, and putting it out there as an opportunity for people to get involved and to contribute to it as well. So I'll leave it there. Thank you.
Fantastic. Thanks, Dan. Has anyone got any questions on Dan's talk?
I was just thinking of something you said earlier, Dan, in your first presentation, and wondering like what other ethical considerations we have for decisions we make that might impact decisions that we make about storage of and provision of data. And the one I was specifically thinking about is, you know, in terms of, we talk a lot about cloud storage, but obviously that requires servers somewhere. And I was thinking mostly about energy use, and you know, when we're thinking about being in a COP26 year, whatever, what we think about those types of climate change related issues that that might have some bearing on this.
Yeah, well, storage is, I mean, a lot of the cloud providers now are moving their storage to more sustainably powered locations. You know, they're looking at the geothermal areas where they can power, but also the cooling in particularly cold areas. Yeah, it's obviously a concern and something we're potentially going to be challenged on. It's not something certainly I've looked at in any detail.
Okay, great. There's a question coming in the chat about whether there's a paper or document anywhere which has all of these horrendograms summarized that you know of, Dan, with regards to where stuff's put.
Not currently, but I guess that's probably an action on our working group to put together a kind of a summary of the, well, certainly the data flow diagram once we've evolved it through discussion, and also some of the examples and potential projects. And I guess that's moving on to the next discussion, is picking up how we want to move this working group forward, and also the potential to look at within this area, and considering the various touch points to the other areas of the big picture and the action plan, how we can make sure we take it forward, and what the potential funding opportunities are.
Brilliant, thank you. And we've got one more question from Chris, got his hand up.
Hi, yeah, thanks, guys. Yeah, it's not so much a question as a comment there on Jen's point about off-site storage and servers. I don't know if you guys are aware, Kate Hendry from Bristol has been running or part of the Net Zero Oceanographic Carbon series of workshops that are going on at the minute, and there's active consultation and consideration about how to deal with exactly those issues within the UK marine science community, and like looking at examples of good practice further afield. So there's definitely a way that we could plug into that, NZOC through the NOC and UKRI.
That's good to know. So moving on to again the funding. So the traditional routes that we've all looked at is the sort of DEFRA and NERC community. I think unfortunately, particularly with data infrastructures and this kind of more foundational projects, it's not sexy, and it doesn't necessarily attract the R&D type funding that that is more traditionally available through these routes. And obviously we do have infrastructure within the UK. You have the UKRI NERC data centres. You have the sort of the Jasmine and Archer HPC clusters, and you have the Medin network that they're all established and operational. But there's questions around how we can potentially carve up parts of this data flow process and identify subsets that we can deliver as fundable elements, or for the other areas of the big picture project to think about when they are developing projects to obviously consider the data management and workflow requirements that would underpin it, and how we can potentially leverage resource from other work that's going on to make sure that we're building the building blocks of this data flow process, but also to look at potentially other sources. I mean, we've talked about other areas within the sort of big data or image-based infrastructures, IT infrastructures. We talked about the medical world, but whether there's opportunities to learn from how they've approached funding through philanthropy. Some of the big tech companies, we talked about some of the opportunities around cloud storage from the Google, Amazon or Microsoft, but also industry engagement as well. And this is always the big one that comes up again and again. And there's various ethical and issues around that level of engagement as well. I'm going to just refer back to the data flow diagram, because this is something we do want to kind of keep in people's minds when they are developing their own individual areas of work, about which points you interact with it and how we can potentially either pull out elements of this as fundable pieces of work, or look at it as a piece across the board. I mean, I think we've got a couple of areas where we've already identified work that's going on, as I say, under the storage of records. We've got this pilot project funded through Medin, but whether there's other areas as well. We've got the work that Kerry was talking about that sits within the green box, but really it's to throw it out to the group to open this area of funding for infrastructure up for discussion. Unless Graeme and Kerry want to add anything now.
No, I'm intrigued to see what people come up with first.
We'll go to Henk first with his hand up.
Thanks, guys. Yeah, I think the two things. If we go for a more centralized model, then centralized funds could be easier to attain through government, but it will require sort of quite a strong bid to make the case. And I think pulling everything that we've discussed together and really dressing up the needs, making them very clear, could be at the heart of that. And the second point, I guess if it's network storage, which is probably the way things might go, because it's easier to chip away at it almost in modules. it seems branding. I mean, it's all about the branding of it, and I like Jen and Chris have pointed out that there are these other considerations to do with the amount of energy required to power the fans and, you know, all of the cooling systems, the storage of the actual information itself, and whether that is an angle to pursue. So I guess just a comment now is that we could consider about ways of dressing this up. You know, we know the pathways we want to pursue here, but it could just be, it could be made easier by thinking of how we brand it. That's maybe a bit obvious though, but it had to be said.
That's great, thanks, Hank and Chris.
Yeah, can I just chip another one in there? Sorry, I keep doing this, but actually, Kerry Howell and myself are both members of the NERC Marine Facilities Advisory Board, and this just strikes me like one of the things that they do at least once a year is put out a call to the UKRI community for suggestions for investment in terms of capital infrastructure, and that could be in terms of facilities like what we're talking about here, or in terms of instrumentation. And like we've just finished a period of reviewing these, and they're going forward. Then they're ranked and scored and put forward to NERC to take up. So there are a couple that we've just reviewed in the last cycle that look very much like this kind of an idea of a networked resource. If it's bigger than something that's of benefit to just one department or one university, it's got much more traction with the reviewers. Now, it's not a guarantee of funding, but it's something to at least put it on the table with NERC, and that might be an avenue that could work. Certainly Kerry and myself can advocate on the group's behalf, even if something was to come in like that.
That's a really good point, and we can certainly take that to MFAB and raise that, because this is about, I mean, this is related to national facilities in many ways, and so I think it should be considered in that way. The other possibility, though, which I wanted to just come back to Henk on, was the digital environment call that NERC had, which, you know, for, let's not even go there, but they were down at our university the other day, and I got the impression that there would be a continuation of that, or they were hoping there would be. And I don't know, Henk, whether you had any joy when you contacted them, or if you contacted them. And if not, then I do think we should potentially go back and speak to them again.
Yeah, I did get in touch with them. They did say that the calls were over in that area, which was disappointing. But I think this is a really big, important thing that needs to happen. And I imagine if we just keep knocking at the door, someone will let us in eventually. So even though that particular call, that series of digital environment calls seems to be coming to an end, just according to the correspondence I had. You know, I was not told to be discouraged. I was sort of encouraged to continue to seek opportunities. And there's another one coming up to do with sort of autonomous remote technologies or something like that coming up. Now this is not entirely connected to that, but I think
it kind of is, though.
It's how you dress it up, right?
No, it completely falls under that. I guess it depends on the full scope of the call, but if we know that there is going to be a call coming up that deals with autonomous technologies, you know, well, this absolutely fits into that, and we should think about, you know, putting things together. I mean, the other possibility is the highlight topics. There's a call for highlight topics at the moment, which we could, as a community, submit a highlight topic, and you know, a community of this size and this variation in backgrounds, I would hope would carry a lot of weight. The other, I mean, these things are just really slow to come through, though. The other thing we could consider is a strategic program fund, an SPF, I think they're called, which is a much bigger thing. But you can submit those anytime to NERC, and you do it as a community, you know, and this is, so these are things that you're not bidding for funding, you're bidding for NERC to have a call on that topic. right?
Yes.
So it's a
yes.
really long process, because you have to go have a call on the topic, and then that's almost like a grant bidding round, and they have to think about it for a while. And if you get through, then you have to write the call, then the call goes out, then you have to write the proposals, and then you submit them. And there's no guarantee you'll get any money at all anyway. But if it's on this topic, the hope would be that some parts of this community would get some funding, right? We wouldn't all get any money.
Yes.
But it's something worth considering anyway, whether we want to put something together. I think it would have a good chance, because it has that, academic, university, research institution, DEFRA, and also industry. You've got all pieces of the puzzle, right?
I think we show them the pie and who's in the pie, and provided everyone on board, provided everyone in the group is on board with that, and is willing to lend their support just in name of organization alone, then it shows that there are a lot of people interested in this. There's a strong voice, and it's not just coming from one sector or one community. So I can't imagine any of us really objecting to that sort of going forward. So really it's we need to think of who puts that together, sort of the group that put that together. I would propose it should fall under project working groups that we've discussed really in this particular session. It seems all three of the groups involved in this are involved in this in some shape or form. Arguably, every group is involved in this, but it can't be taken forward by everybody. So I think we make some notes on this, but going forward, I would recommend that someone from the session here, from the people involved in the groups in the session here, put that together, and I can chip in to share what information I have, which is very little, but a little bit of information on that event that's coming up to chip in on the autonomous remote technologies interest.
Okay, I've got a hand up from Chris to come back in.
Yeah, sorry again. I was just thinking that there might be a mechanism for joint UKRI NSF funding if we can try and tap in the guys in the States as well. There are several mechanisms that I can see that, even thinking there's a UK trilateral funding pot for NSF linked to UKRI and the Republic of Ireland, like trilateral, because I've had my eye on that for a while, but it has to be led by an NSF bid, and basically the UKRI kind of match fund their various sections of it. So if we were thinking about a kind of, a joint kind of US and Northwest Europe venture, could be a really nice way to do it.
Yeah, I don't want to get ridiculously large scale, but I'm about to. And of course, there is the Decade of Ocean Science, which I think we shouldn't forget about. There's a huge part of that, which is about new technology and enabling technologies, particularly. And this quite clearly fits into that remit, if you were going to think of it on that larger scale that Chris suggests. And so there are questions going around at the moment about the UK's response to this, and how that's going to be handled. And they're also looking at SPFs and highlight topics as a mechanism for that. But there is, through NERC at least as well, agreements with large grant agreements where you can submit with NSF and Ireland, as Chris mentioned, but also with Brazil as well. There's these agreements in place. So you could try and tap into that much bigger picture of global stuff. And in fact, Kakani's presentation, you saw she kept saying ocean shots. Well, ocean shots is kind of the beginnings of the American response to the Ocean Decade, as they asked for these, big shots, these ocean shots that might feature as a US contribution to the Ocean Decade. So there were lots of people asked to pitch, and obviously Kakani pitched this project. But so it's not beyond imagination, but it's perhaps, I don't know, it's never sure, do you go in massive or do you go in small? Who knows?
Yeah, it's the go big or go home. Yeah.
Okay, great. Has anyone else got anything they want to add on funding? Any ideas of potential funding avenues that we haven't chatted about that we could potentially consider for this work? Is there a final presentation, Dan, or have we?
Well, no, I mean, we've got 10 minutes at the end to sort of wash up of any questions, but the only other action that I guess I want to put onto the group is for volunteers. So obviously Kerry's leading the AI approaches group, which is already active and has people involved and has met and discussed. The data catalogues and data flow work, we've kind of only just got together as a project working group on that. We've got a few people who've expressed interest, but really I wanted to ask people if they can just put a yes in the chat if they would like to sign up for or to email. It's pretty easy to email in to you, Jess. Is that all right, as the facilitator? Sorry, I've just thrown you under the bus there. To be involved within the data catalogues and flow work with the sort of the caveat or the context that it is all being taken forward with a sort of a MEDIN branding on, as well as far as the standards work that that Graeme mentioned. So yeah, we're looking for volunteers to either be actively involved in the group or to be passively involved, as Hank mentioned yesterday, to just receive the information.
And I think the other aspect on top of that is, we're looking for contributors, not just from people that will, contributing from a technical perspective, but it's part of, this needs to be customer focused almost. So it'd be really good having sort of steering members, as it were, that could help drive the direction that's in a sort of useful and practical direction.
Yeah, it's the questions that they want answered from an infrastructure that we're hopefully building.
Mm-hmm.
Okay, great. So if people want to get in touch with, just email the big picture email address that's been circulated a couple of times today already. It's in the chat higher up, and we can make sure to put you in touch with Dan and Graeme on that group. And Graeme's on it and posted it again in the chat, so we've got it there. I guess it's worth saying with that I think all of the project working groups would welcome people coming in if they, if they're here today and they feel that there's something that they'd like to get involved in, but they're not already a member of. Please feel free to contact the big picture group and we can put you in touch with the right people, because it's not by any means a closed call. I think it's all about the more the better. I've forgotten the phrase for that. But yeah, so yeah, does anyone have any kind of follow-up questions on any of the talks that we've had? I'm aware there's a lot of information that's been circulated today. It's been really interesting. So there's the data standards and the MEDIN data flow that Dan's talked about, and the image catalogues that Graeme's talked about, and the AI stuff that Kerry's covered. So if anyone's got any questions on any of that, if they want to raise their hand or post in the chat now. Hank's got a question.
Well, just another comment really, that there's been a lot of information covered in the last sort of 2 hours, an awful lot. Just scanning through the chat there, you can sort of get a flavour of some of the discussions. There have been numerous links added to it as well. Over your lunch break, you can check those out if you want. We will keep a record of that, and that will go into the report in some shape or form, probably like a distilled version. Yeah, just allowing a little bit of time for questions now, but then just before we end the session, I just want to I want to share that we've set up kind of a networking call if people want that, but I'll just come in at the very end of the call if you don't mind.
Yeah, that's great, Hank. I have a question with regards to the data storage discussions that we've had and the big green box on your flow chart, Dan. With regards to the storage, when you're talking about that, is that, I guess, would that how do you see it? Do you see that being an imagery catalogue platform at that point, or is that just a repository of the data as a whole? I think I'm getting myself muddled between when we're referring to data catalogues and image catalogues when we're talking about that flowchart.
Yeah, good question. I don't think we've got the answer. I mean, like as Graeme pointed out, you know, there's different solutions at different stages depending on different use cases as well. Certainly within what the Medin side of things, what Medin's set up for is to archive the original data, and there's going to be use cases on top of that, and that's where you would get potentially this proliferation of different catalogues to support those different use cases.
Yeah, that's great.
Graeme? Yeah.
No, I was just going to say it highly depends, and it goes back to even at the level of, you know, do we, just me delving into the detail again, but you know, do we keep the annotations actually separate in a separate system, but have it talk to a catalogue, or do you put the annotations inside of the catalogue? There are significant pros and significant cons to both, you know, to both approaches, and they're both in that green box, as it were. And as Dan says, the answers are dependent on the questions that people ask and what people need to get out to it, and you know, their requirements, which is why it's quite good to have that discussion, not just with us technical people in the middle, but the customers.
It is all a little chicken and egg, isn't it? I mean, and that's, yeah, there's a risk of us going around in circles on it, but it needs to be driven by the questions.
Mm-hmm.
Great, thanks. Jen, I don't know whether you want to come in.
Just thinking that maybe we don't need to necessarily reinvent all these connections. Like, I'm sure lots of people have thought of connections as a result of these talks, but which is great, and for people to volunteer through the email address. But back in those heady days of mid-2019, when the Plan Development Group was making our own horrendograms, we had lots of, basically lots of boxes with a gazillion connections between all of them. It was like a bowl of spaghetti. And so I guess I was just thinking we should maybe not lose that information. And even if people haven't necessarily volunteered to help with something, we may be missing a connection that's important there. And so we might want to revisit what some of those are, and, you know, not force people to volunteer or throw anyone under the bus, but just kind of encourage those connections that we've obviously acknowledged already are important.
I think that's a really valid point there, Jen. And Chris, I think you just pipped Henk with your hand up. So do you want to come in first?
Right, I do. No, I was just thinking this is quite interesting. Again, that there are a series of other kind of research communities that aren't necessarily interested in the same sorts of outputs as we are, but they're using the similar sorts of data products. Like, I can think, I work in a department with several maritime archaeologists, and for instance, like, and I'm quite plugged into a network of ecologists in North America that are looking at similar sorts of aspects, but with common data sets that in other user groups that we mightn't actually be considering here, that could be potentially providing us with more information that could help to make a stronger case. So it's maybe, yeah, just like we were talking about earlier on with the sediment, the geological, geomorphological communities as well. There might be other groups too.
Yep, that's great, Chris. I definitely think we should be linking in as much as we can. Henk?
Well, quickly on Jen's comment, I've been thinking that too, Jen. I think there needs to be like some sort of like a review of those tasks periodically to make sure they're up to date, and to add in the new ones as they go along. That can be a nice job for the Action Plan Coordination Committee going forward, and any other volunteers. And then on Chris's comment, you know, is it a bit Field of Dreamsy that you sort of have to book them and then they will come? You know, it's like these connections are all out there, and I feel now that we've got a big enough group and voice and some good ideas on the table, you know, it's almost like we need like, I don't know, flagship projects or something to sort of go out there into the big wilderness to talk, and sort of, I guess, using these existing linkages and conversations, but then just moving, sharing the things that we are coming up with. And I think one of the things we're hoping to do with this workshop, we'll have a video record of the sessions, which people can view at their leisure anywhere, but anywhere in the world as well. And then there'll be a report to sort of summarize things, which people can look at. And then there's the back history of everything that's gone into this effort so far, plus hundreds of linkages to sort of various pieces of work that aren't connected to this, but can be related. So it really sort of is mind-boggling, really, just what is actually possible. But really it needs to, well, I think now is the time for those bigger steps to be made. And I think, yeah, I'm just glad that seems to be where we're headed anyway.
Okay, great. Well, considering we've only got a couple of minutes left in this session and people's stomachs are probably rumbling right now and in need of caffeine to top things up, draw the session to a close there. Thank you everybody for your contribution in the chat and your contribution to the talks through your questions.